factor is the measurement of the relation between the voltage and the current and the AC waveform. So if the voltage and current are in sync, exactly reaching on the same point, then we say the power factor is 1, which is a resistive load. So we add a resistive load in, heating elements, that type of equipment, then the power factor is exactly 1 because the current and the voltage are in sync. If we then go and add to this electric circuit inductive impedance, which is transformers, overhead lines, electric motors, then the current starts falling behind the voltage and it is lagging. That goes, so now we have a 0.9, 0.8, something like that. If we then go and add a capacitive into the circuit, capacitive impedance into the circuit, like a capacitive correction bank or something like that, then we drag this current back to be in sync with voltage, and that we call power factor correction. VoltVision goes and fetches the power factor metrics, all the energy meters and protection relays that are available in the system. So we have power factor for every piece of equipment. We know the bad power factor comes, we know where the good power factor comes from. Then go and store it up in the cloud. While we're storing it up in the cloud, we also do the calculation of how much capacitive reactive energy is required to correct the unity. And it's there, full time, 24/7, all the time. If one goes and you do a survey, you'll probably get data for a week, 2 weeks, and then the data is incomplete for the full design. Whereas we have the whole spectrum of data 24/7. VoltVision's power factor solution reduces cost in 2 ways. First of all, because we have been fetching all the power factor correction data, we've got a huge amount of data 24/7 to give them the data for a good design. And then secondly, once they've installed the power factor correction pack, we continuously monitor it to see that the performance is still up to scratch. In fact, one of our clients, the performance went down, we alerted them to that, and then they configured, it took them 5 minutes, they configured the power factor correction bank to get back to it was, and now they will save $40,000 per month since then. Power factors cost industrial processes on inefficiency. First of all, the utility that's supplying you the power has to install bigger cables, bigger overhead lines, bigger transformers, which is a direct capital cost to them. And you pay for that capital cost because they'll just keep put on your bill. They'll make you pay for it somehow. And then on your side of the fence, you also have to go and put more capex into your cables and transformers and design equipment a bit bigger to be able to supply the megawatts you require because you've got a back power factor. So you're also paying additional capital. And then we have the so-called heating effect of the transformers and cables because of the I squared R losses. It's a technical term, but it's this formula for heat created due to the inefficiency, and it's the square root of the current times the resistance. And because the power factor is bad, the current goes up. So you got that additional heating loss, which you're just throwing away. It's money you're throwing away because you're paying for it in kilowatt hours.